So vacuum system, really easy way to diagram this. I like symmetrical stuff, it makes it easy. Let's see here, it's been a while since we've done this. Pretty much. There you go, there's your symmetrical drawing. Really easy. I got an attitude indicator, I got a heading indicator, right? Those are my vacuum driven items. So I've got flow through here. So on this side I've got the pump. I'm sorry. Back. On this side I've got an air filter. Right here, this is a pressure regulator. That's why on a katana, if you have low suction, the mechanics walk out with a screwdriver, open up that pressure regulator, your vacuum system's good again. Okay? On this side I've got a suction gauge, and I've got an engine-driven pump. So that's pretty basic. Any questions on that? So really easy, symmetrical. Whenever you come up with diagrams, try to come up with a simplified diagram, and it makes it easier. The vacuum system suck or blow?
Suck.
Why? The vacuum is more powerful than compression. So if you were trying to move fluid or whatever, it's just like you're at the banks or whatever, they suck them up the tube. Because if they tried to blow them up the tube, it would take a lot more because the air molecules compress. And so compression takes a lot more, whereas a vacuum, the void, hence why low pressure systems in the weather pattern are so violent. So vacuums are just stronger. Okay, VOR. The VOR works based on, it sends out two signals. So it sends out one signal that's omnidirectional, the other signal is a sweeping directional signal. It compares the timing between the first signal and the second signal. That's what determines your radial. So does a VOR really send out radials? No. It actually doesn't send out anything other than two signals. Our timing of those two signals is what we call a radial. Basic holding principles. I have a hold. Standard holds are right-hand turns. Right-hand turns. Basic terminology. I've got my inbound leg. Why is it called inbound? Because I'm inbound to the fix. So I always fly inbound to the fix. You'd be surprised how many students can't remember if they fly this direction or this direction. So drill that into their head. You always fly inbound to the fix. So that's the easiest way. They'll look at this and they'll go, oh, it's a left-hand hold because they think they're going this way. So solve that right up at the front. Inbound, it's a right-hand turn, obviously. I got my inbound, I got my
outbound.
Outbound.
You're on it.
When I'm flying an inbound, I'm flying a course. When I'm flying outbound, I'm flying a heading. Once again, drill that into them. They turn outbound and they start trying to track the needle, and you're like, "We're going! You're outbound!" So clarify that. Outbound's always a heading. Inbound's always a course. Okay? I've got my non-holding side, or my unprotected. I have my protected, or my holding side. They're synonymous. So when you talk about that, oh, well, why don't we want to do this or that? Well, because we don't want to be on the unprotected side.
What does that mean,
side.
I guess?
What's
Like there's no radar out there, there's other planes out
No,
there.
so what it is the way that they determine it, it's actually not published because it does depend on altitudes and all this other crazy crap. But what it basically is this side is only protected for like that much, whereas this side is protected for like that much. So you have more space on each side in which they protected means you're not going to slam them out. Okay. Right here at the edge of the limit, how much terrain clearance do you get? Nothing. 0. That's what it's measured for.
Plains or wherever there's no terrain, well, theoretically no terrain, why do they request which way you do it? That's what they want.
Because they know which side you're going to be on, so if they've got other traffic, they know that you're not out here, you're over here. So if you're over here, they can vector somebody out over here. And so it's, yeah, it's knowing where you're at, and so that if you're, because I mean basically it's a parking lot in the sky. So if you're in the parking lot, where are you? So that's kind of how it is. But the outer limits are 0. Now, the limits, people are like, because we fly Diamond Stars, you always have to constantly remind people that you're not going to fly Diamond Star your whole life. You're going to fly something fast one day, and guess what? All of this is based on maximum speeds. If you're at the maximum speed and you do the wrong hold entry, you will exceed this limit right here of protection. And so that's the problem. It's all about keeping you safe. Well, wouldn't it be easier to, well, yeah, it would, I guess, if you're a Diamond Star, but if you start thinking that mentality, what are you going to do when you're in a jet one day? You're going to revert to primacy, and you're going to do the same dumb thing you did in a Diamond Star. So really get them thinking that we're not flying Diamond Stars. We're flying jets. So how do we do this? Okay, questions, basic terminology?
Is there a specific distance from the inbound course?
For the protected, unprotected? Yeah. It varies. Like I've tried finding a hard number. Gotcha. Like I've heard people say it's like 6 and 4 or something like that. But it varies by altitude and because of the maximum holding speed. Gotcha. So as you go up, it gets bigger. And they've got this whole crazy diagram. If you look up TERPs, there's like this equation they use. Yeah, so there's no real published number. I think that people say the 4 and the 6 because that's probably what it is for the slower holding speeds, or probably. I don't know. Okay. Easy enough? I've been working on flow of this.
We'll let you know how it goes.
Thanks, appreciate it. Okay, so here we go. When we get a hold clearance, okay, this is where we go wrong when we teach students. We need them to understand how it works. So I get a hold clearance. Another funny story. I made this up and was like, oh, this is so cool. And then I opened the AIM one day, and guess what? It's an AIM. So anyway. All right, so when I get a hold clearance, I need to understand how it's broken down. The first thing that they're going to give me is the location of the inbound leg in reference to the fix. Okay, location of the inbound fix. How's it given to us?
East, west, north, northeast.
There you go. It's a cardinal direction. Cardinal direction. Okay? So if I think about it, if I was to draw it out, I've got my fix. What can a fix be? It can be a nav aid, it can be a distance, it can be crossing radials. It's a definable point is what it is. Some way I can define it using my navigational sources. Okay? The location of the inbound leg in reference to the fix. Hold southwest. Guess what? That means that my inbound leg is going to be somewhere in that zone. Guess what? That means that my inbound leg is going to be somewhere in that zone. Not quite sure where yet, but it's somewhere down here. I'm going to be flying inbound to the fix. Okay? Got that. Number 2 is going to be the actual fix. Well, where the heck is the fix? I need to know where I'm holding off of. Hold southwest of the Fairfield VOR. There's my fix. Number 3 is the navigational reference.